You can write the whole -1/2 thing, but then you know by now that you have to multiply by the derivative of the inside function. Okay,
Mhm.
that's the chain rule. So I'm just going to rewrite it here. I'm going to go back to the x plus y. So it's 1/2 square root of x plus y times, well, what is the derivative of x plus y? Well, the derivative of x is
Is 1.
1. The derivative of y, if it's like an x, is 1. But like I said, you put a dy dx whenever you have a y. Is that okay up to this point?
Yeah, yeah, yeah.
Okay, so now from here, there's really no more calculus. It's all college algebra, pre-calculus. You're just manipulating the equation. You want to get everything on one side. On the right here, I guess, what would your teacher? So there's a couple of things you could do. You could multiply everything by 2 root x plus y, or you could hold it with each of these. I actually don't know what an instructor would prefer here because it really is dependent on them. But it's dy dx over 2 square root of x plus y like this. A lot of writing. So depending on
Mhm.
your comfort level with algebra, manipulating equations, we want to get the dy dx's on the same side. So generally you move left and then you move these other ones right. Okay. So we're looking at 4y cubed dy dx plus dy dx over 2 square root x plus y equals 1/2 square root x plus y minus 4x cubed. Once you get them on the same side, the dy dx is you factor out a dy dx from both terms, or terms, could be
Mhm.
more than one. 4y cubed plus 1/2 square root x plus y. And then nothing changed over here. I'm going to copy and paste this. Again, a lot of writing here, although you can shortcut it a little bit. Then you divide everything by this. And it's not uncommon for the answer to be extremely messy. Some instructors are totally okay with what I'm about to write, which is the unsimplified form of this. Like this is your answer.
Okay.
And it looks bad. It is bad. It's unsimplified. Some don't care. I probably wouldn't give a problem where it led to like this conflict for the student. But if you
Okay.
did want it to simplify, I'll just comment here. We won't actually go through it all. Is you would multiply everything by 2 root x plus y, top and bottom. So if this were like a multiple choice thing, it would definitely be simplified in that way. And I'm happy to work through that if that's what you need. But that is the final answer there. What does it mean? I don't know. It doesn't really mean much. It's just another derivative in this part of the course.
Okay.
All right, so I'm just going to step away for 30 seconds. Working from home, I sometimes have to grab a door or something off the stove, but I'll be right back with you. You want to share your screen and get the next problem ready?
Yeah. Yeah,
We'll
yeah, yeah.
start on here
Go
in a
ahead and do
moment.
that. Mm.
All right, so let me grab part A and part B's here. Part
You
B.
got it.
Scroll down. Is that all that there is for part B?
Yes.
Okay, I got it then. Okay, so it looks like you're fast approaching a test on derivatives, which means you do have to know the product and the quotient rules here. So let me go ahead and share
Of
my
course.
screen. Look at that, you already knew how you already stopped sharing your screen. That's good. You're becoming a Zoom
Oh,
expert. I like that. I like that. That's good. Uh,
quit.
the Let me drop in the chat here a reference sheet. I know you've taken one. I think you said you're just doing this and you're done with calculus. I always find it's useful to have a table of derivatives and then later in this course, a table of integrals. They're all here. Sometimes it's worth printing out here to have side by side here. So in class, are you guys using like F and G or U and V when you're working through these?
Yeah, we're doing f prime, g prime. We
Okay,
we we know
so
the product quotient.
yeah, I don't really like F and G, but it is
Mm.
kind of the common one. I tend to use U and V with students that are seeing it for the first time here. So you do have to be able to take the derivative of F prime or F and G. That square root of R, it is R to the 1/2 power, but you'll find if you can just get it to rewrite it like this, that it's a real savings in time with your derivative. Uh, Next one is 6R. What's the derivative of e to the r? Do you remember that
E,
from
it
class?
stays e to the r.
Days itself. Second one is 3r squared. All right. Now the derivative f prime of r is, and there's a lot of ways that you can do this. Like there's what the classic product rule from the textbook says here, which is what we're looking at here. F prime g plus fg prime.
Mhm.
What you're really doing though is you're really combining diagonally. You're taking f with g prime and g with f prime, and the order doesn't matter because it's multiplication and addition. The order doesn't matter. Remember, those are commutative. So as long as you group them all to get, group it together appropriately, you're going to be fine. Now, I like to show it in parentheses like this because
Mhm.
it's clear what you're grabbing and not grabbing. And then f is square root of r minus 3r squared times e to the r plus 3r squared. Should you simplify? That depends on the instructor. What does your instructor say?
Simplify by.
What? Oh, that's horrible. Um, wow, really? God, you got a terrible, terrible
Yeah.
instructor. Yeah, that's brutal. I'm just gonna make a note here to simplify because I don't think you want us to use our, unless you really want me to. I'm happy to do that, but we'll
On
waste a lot of time here doing this.
on the question, it does say to simplify. So that's the only
Okay,
problem I really have with this kind of question.
I see.
It's just
So
just
yeah,
combining them.
yeah. So the next steps are to FOIL here. So it's
Okay.
it's 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 whatever is required. Okay, we're gonna FOIL. All right, minus 6r e to the r minus 6r to the fourth. Okay, now we go to the other one. Plus square root of r e to the r minus 3r to the 5/2 powers. Now, why 5/2? Because when you multiply and you have the same base, the exponents add. R to the 1/2 times r squared is r to the 1/2 times our plus 4/2 because 2 is 4/2. That's how you get the 5/2.
Mhm.
The inner here is minus 3 e to the r squared minus 9r to the fourth. Okay, and then you start looking for like terms, which there really aren't any um, that I can see. I guess there's one here. There's this minus 6r to the fourth, this minus 9r to the fourth. That's it. Everything else is not really the same. You could maybe make the argument that you could factor out the 1/2 squared of r from the first two. Maybe. I mean, I don't know. I don't really have a strong opinion on that. One thing you might do as you combine terms or write the terms is to cross them out so you don't neglect to write some. That's a common thing to forget. Uh, Minus 6r e to the r plus square root of r e to the r minus 3r to the 5/2 minus 3 e to the r squared. This is a square root down here. And again, I mean, you could make the case that any of them with e to the r, you could factor out an e to the r out of them. Like, I don't know how far you go on these. Yeah, minus 6r plus square root of r minus 3 e to the 3 3r squared. Like, I just don't know what is appropriate. You sound like you don't have a very good instructor, because the general consensus is you don't simplify these things.
I don't I don't know how far it is. The only thing I really struggle with is simplifying.
Okay. And that's just maybe you get some more clarity from your instructor. Maybe I would even ask the question. I was like, hey, I was working on this problem over the weekend, and like, I don't know, where do I stop? Like, how far should I go?
Yeah.
And it's, I mean, hopefully their answer is more, it's clear. I mean, if they give you an answer like, well, you should stop when you should know when to stop, well, you're in trouble. You got a bad instructor. Okay. B is, they tell you thou shall use quotient rule,
Hmm.
but and this is important. If this were on a test or a quiz and they didn't specify, you would not use quotient rule, because you would divide each of these by the 7x squared,
Oh.
and you would simplify. So on the left one here would be 2/7 x to the 1/2 over x squared. You would end up subtracting this and end up getting 2x to the minus 3/2. On the right, the x cancels that x, you'd get plus 2 over 7x, or plus 2 over 7x to the minus 1, and you would use power rule. Okay. But since you can't do that, since you have to do it the way that they tell you, we will use quotient rule. But just keep that in mind. I mean, that's a classic test question where it's like, they just say take the derivative, and there's a shortcut.
Okay.
All right, so let's get going on this problem. So there's the top, which is f, 2 square root of x plus 2x, g, which is 7x squared. Can you give me the derivative of f prime, please?
Would it be 2 times 1 over 2 square root of x
Yep. And
plus
that does reduce to this, plus
plus 2?
plus 2. Good. All right, so unlike product rule, quotient rule does require you to do it in a certain order.
Mm-hmm.
Okay. And I prefer like the words, so it's bottom times square root of the top minus the top times root of the bottom over the bottom squared. You can use whatever you want. The more math you take, the more you can do it the way you think is right, and you get less friction from your instructor. So to keep that in mind. So it's 7x squared times 1 over square root of x plus 2 minus 2 square root of x plus 2x times 14x all over 7x squared squared. And the typical consensus is you don't simplify, but you're going to tell me that you simplify, don't you?
Yeah. Yep.
All right. So we're going to do this in sort of in stages. The first thing, and this is pretty hard, is this is really 49x squared. And then you have to recognize that there's an x. You can factor out an x from this one, you can get an x, and from this one, you can get an x,
Mm.
which cancels with this one. Sorry, x to the fourth, which cancels with that. So it ends up being, and that's why I said it's kind of like a lot here. It ends up being 7x times 1 over the square root of x plus 2 minus 2 square root of x plus 2x times 14 over
Okay.
49x cubed. But then you also notice that these all have a 7 in it. 7,
Mm.
7, and 7. So this becomes 1, 2, and 7, like that.
Oh. All
All
right.
right, so that's a little bit more. So let me, and the more you can do this without writing all of this, the better. But I get it. As a student, you're like, I'm not in this, I'm a, I'm never going to use this stuff again. All right, next thing is the square root of x on the bottom here. So this isn't written very well, but the square root of x is really like on the bottom of the fraction. So you end up multiplying the top and the bottom by the square root of x. So on the on the top here, I mean, you're multiplying everything by it. You can sort of see like it's going to go into everything. So it goes into and maybe what I should have done here is distributed first, which I think I'll do because that'll be clear. X over square root of x plus 2x over 1 minus 4 square root of x over 1 minus 4x over 1 times the square root of x.
Mm.
And then on the bottom here, this is 7x to the 7/2 power. For the same reason, this is really x to the 1/2. So now you can see when you distribute the square root of x in, all the way on the left, it cancels. So you get x plus 2x to the 3/2 power minus 4x minus 4x to the 3/2 power over 7x to the 7/2 power. And then we can combine like terms again. So we've got x and that. So you've got minus 3x minus 2x to the 3/2 over 7x to the 7/2. You can factor an x out of the top. So you get minus 3 minus 2x to the 1/2 over 7x to the 7/2. And that x cancels with this down here to make this 5/2. And now you've got your final answer.
Mm.
All right. So that will do it for us for the try it out lesson. I'm going to go ahead and stop the recording here.